Alrighty, we're going to use patterns to find products of polynomials. So it's going to be stuff like a plus b squared. And there's a pattern to this. I guess you could call it a pattern. It's, if you were to write this out, what you really get is a plus b times a plus b, right? Because it's squared. And then if you were to actually then to go ahead and start distributing and everything, here's what you get. And I guess this is why I say suppose it's a pattern, because you get a squared plus 2ab plus b squared. And that is for a plus b squared. And there's one other that we've got. There's a minus, well, I guess there's more than one other. So here's a minus b squared. That one looks like this. It's a squared minus 2ab minus b squared. I'm sorry, plus b squared, because a negative b times a negative b would be a positive b. And so now this is where it's like, oh, hey, if I have a number plus another number, the whole thing's being squared, I can figure it out like this. A number minus a number being squared, I can figure out that by doing this. And I said, oh, wait, there is one other one. And it is a squared minus b squared. So here, I'm actually going to go out here to the side and label it. Here are basically our three patterns, so to speak. And this one ends up being a plus b, a minus b. Okay? So we're going to use these three patterns to therefore basically cover a bunch of this. Now, if you're in class, if you got the notes in class, this section is a little bit tricky, so I might actually save it till the end, maybe? So anyway, let's go through this stuff. Number one is negative 6p plus 3 squared. So it fits this pattern. I'm not going to zoom out too often. In fact, if you want to, stop the video, copy down 1, 2, 3, because that's what you're going to be using to do this assignment. Because everything will fit either this, or this. All right? Okay. So number one, I have negative 6p squared plus 2 times negative 6p times 3 plus 3 squared. Now, I didn't put him in parentheses. I guess I probably could or should, but I didn't. And then now we simplify this. Negative 6p squared is 36p squared. And this next part, 2 times negative 6. So basically, I'm just going to do this in my head. And hopefully the numbers that they give us are doable in our head, right? If not, okay, then just write it out. 2 times 6 is 12. 12 times 3 is 36, and it's negative 36. And then don't forget the p. And then 3 squared is just 9. So there's number one. Number two, it fits which pattern? It fits this one because it's a number minus a number, it's being squared. And that's what we have, a number minus a number, and it's being squared. So here, I didn't write it on the first one. Maybe it would have been helpful if I had said, hey, well, no, because like I said, they're right here, right? So here, I'm not going to write it out. It's going to be a squared, a squared minus 2 times a times b plus b squared. All right, so what does that end up looking like? That is now going to be 9c squared. 2 times 3 is 6, and it's going to be negative 6. C times d is cd, and then plus d squared. Done. We have a number plus a number, and it's being squared. So we're going to have that first number squared plus 2 times the first number times the second number plus that third number, that number squared. If my voice sounded weird, I was about to sneeze. So anyway, now we just simplify this. 5x squared is 25x squared. 2 times 5 times 2, that is 20. And then xy, because, x times y, plus 4y squared. That's number 3. So for 4, 5, and 6, well, and 7, and 8, and 9, they all fit this one. So it's just going to be a squared minus b squared. So if you're like, which one is going to be a, b, a, b. I mean, that's pretty much it. And why is it going to be a, b squared? Because what we have is a number plus a number times the same a minus the same b. So 9 and 9 checks out, plus 4q minus 4q. So there's the scenario, right? And then it repeats over here, plus g minus g, but the 2/3 are both the same. Plus 8 minus 8, but the 3 m's are the same. Same. So this will follow that a squared b squared pattern. So we have 9 squared minus 4q squared. 9 squared is 81, and this is going to be 16q squared. And that seems so wrong, but there it is, right? It's just a squared minus b squared. And the one thing I guess that you should know is that I don't care, if this is positive or negative, it's just going to be that b, right? A plus b, a minus b. That doesn't really tell you about the sign of this term, right? So that's why I did 4q inside the parentheses squared and the negative outside, yeah. So right here, we have 2/3 squared minus g squared. This is 4/9 minus g squared. Now, you know what? I did not write, so hold up, let me back up. I suppose it would be most proper if we were to write this in standard form, but I'll tell you, I'll take both of these because of our form right here, like our pattern, right? So really, I'll be putting it in standard form, and then accepting both of them, okay? Plus, it would be kind of nice for you to see the fact that this right here fits the pattern, but this doesn't fit the pattern. And notice how you can just rearrange it to then now you could go, oh, wait. So I could go from this box up here relatively quickly. Same thing with this one. Let's do number 6. Number 6 is 3m squared minus 8n squared. That's 9m squared minus 64n squared. No need to rewrite that. That is in standard form. Generally speaking, if you're curious about how which variable goes first, it's just alphabetical order. Number 7, 8 squared minus 3u squared. 64 minus 9u squared. And the other acceptable answer, minus 9u squared plus 64. There you go. Negative c squared minus 9 squared. We get c squared minus 81. Already in standard form. Doesn't need to be rewritten. Now, something interesting to point out is all of the other ones. So I mentioned, like, in a brief moment when we were learning this stuff, that this form right here can easily be factored. And what I mean by factoring is if you had written this right here, that you could easily rewrite it in this format, which is a form of, it is factored, okay? So all of these could be factored really easily, really quickly. 81 is 9, and 16 is 4, and q squared is q, and 64 is 8, and negative 9, is that 3 in the u. But this one, and I might just be talking randomly, and this is not necessarily needed, it would be difficult to go from c squared and then just to go, it's negative c. We wouldn't have naturally thought that. But if you were to go ahead and just use the distributive property here, you would still get c squared minus 81. So there is no great way to communicate that, hey, this is supposed to be this. All right, slide into the 9. Number 9, negative 3s squared minus 7t squared. 9s squared, 49t squared. Done. Like I said, I'm going to save 10, 11, 12 for last just because its thinking is like in a different direction a little bit than the others. 13, describe and correct the error in finding the product. If you had this, then it fits this, which is this. So right away, you know that this should be a negative. This should be a negative. And if you're like, I didn't know that, well, then just go right here, and they haven't made a mistake yet, okay? And if you were to just use the distributive property, x times x is x squared, x times negative 5 is negative 5x, 5 times x is positive 5x, 5 times negative 5 is negative 25. X squared, gone, minus 25. Oh, look, they're supposed to be a negative, right? So there's your answer. All right, we got a word problem. Yeah. My number one piece of advice is to draw a picture. I do it every time. A square picture. Oh, look, it's a square. You don't even have to draw a perfect square. That's not a perfect square. Has a side length of 20 centimeters. Okay, 20, 20, 20, 20. We're on a roll. You trim X centimeters off two adjacent sides of the picture. I think what they've done is they're cutting off a square that is X by X. So write a polynomial that represents the area of the trimmed picture. Oh, okay. So what they're wanting is this area right here. What would that area be? Gotcha. So the reason they're using a square is because area of like the blue square, I'm going to write area sub B is going to be side times side. Well, that's 20 squared. And then the area of the little green square, so I'm going to area of little green square is side times side, that's x squared. So then the area of the yellow square is just going to be 20 squared minus x squared. So have we done it? Write a polynomial that represents the area of the trim picture? I think so, yeah. So there it is. That's a polynomial. Now show how you can use the polynomial to find the area of the trimmed picture of the yellow when you cut 5 centimeters. So now they're just saying, hey, listen, dude, it wasn't X, it was actually 5. So instead of us, doing all sorts of random math, what we're going to do is just go, okay, it's 20 squared minus 5 squared. And this is where, again, we're going to go back to our pattern. If you have a squared minus b squared, it's really a minus b, a plus b. So this would be 15 times 25. And that's, I guess we could go ahead and do that math. 25 times 15, that's 5, 2, well, that's 125. I don't know why I didn't just do that. Okay. It is 345. So 345 centimeters squared. There we go. And if you're curious, by the way, the original picture was 400 centimeters squared. So yeah, if you were to chop off a 5 by 5 little piece, it takes about that much out of it. Right, two binomials that have the product of that, and then explain. Let's see. Well, these are what the binomials are going to look like. It's going to look like this stuff. I guess I don't even know why I'm going back to point to that other than just to help go, hey, this is going to be our level of thinking, okay? So we could have 5r plus 7 squared like that, right? And really, this next part is like, well, I'm a little not sure what exactly they want as the answer. So that's true. That's true. So is this. And so is this. So I'm not 100% sure how they would want it in any other way, because if you're going, well, what about, this guy? Well, he has a negative, and we're not going to be able to just all of a sudden make a positive. And in fact, if you go look at our examples, we didn't have that anywhere. Not here, not here, not here, right? That was the only negative, and he didn't get us, he gave us a negative here, right? There's a negative here, that makes that a negative there. Positive, positive. I thought for a second that this guy might have done it, but if he's negative and these are both positive, then it doesn't work. Here, let me try one other one just real quick. What if it was all negatives? Let's try that. What if it was negative 5r minus 7 squared? So you'd get negative 5r squared minus negative 5r, I forgot my 2, there's a 2 there, negative 7, and then plus negative, oh wait, yeah, that might work, because that's just b plus b squared. So 25r squared plus, 2 times 5 times 7, that's 70. R plus 49. Okay, yeah, that does work. Cool. Okay, so then I figured it out. This guy and this guy. Those are our answers for this. And what's my explanation? There's my explanation. There's my explanation. This one fits the pattern. Hopefully you watched all that and were greatly informed. Find the product. 3x squared plus 7y squared squared. Well, this is the a plus b squared, so it's just going to be a squared plus 2ab plus b squared. So just be careful to keep, these squareds in there. And then now this is going to be 9x to the 4th plus 2 times 3 is 6. 6 times 7 is 42x squared y squared plus 49y to the 4th. There's that one. 17. Okay, this one is going to be the one that fits a squared minus b squared. So that's nice, because now it's just z to the 4th squared minus 3w cubed squared. So we get z to the 8th minus 9w to the 6th. I like it. Last one, find k so that this is the square of a binomial. Okay, 5x. Okay, so hang on, I started launching into an answer. Let me launch into an explanation. Square of a binomial is a plus b squared, right? And that was a squared plus 2ab plus b squared, right? So this is 40x. 40x equals 2ab. And what we're going to say is our a is really 5x, right? That's really a. So right here, hang on, I'm switching colors. This is really 40x equals 2 times 5x times b. Okay, so this is 40x equals 10x times b. Divide both sides by 10x and you get b is 4. So b is 4, so that just means we're going to get 5x plus 4 squared. And then, we were told to find k. So k is just going to be 16 right there. And if you're like, wait, why is it 16? Well, because this is our a plus b squared, and b squared is in that k position. Let me erase this because I kind of covered it up. K is b squared, right? Because of this. So what is b? B is 4. 4 squared is 16, and I'm going to circle it again. 16. Yay. Okay, so back over here where I was like, hey, listen, these are a little bit, the thinking kind of goes a little bit offline from the other thinking that we're doing on all these problems. So let's check this one out. 27 can be written as some special products. And in fact, what are special products? These, right? So we can look at 27 a couple different ways. We could call it 30 minus 3 squared, because isn't that 27 squared? It sure is. You could look at it as, by the way, I should erase these. These are not negatives. This is just me like talking. I could call it 20 plus 7 squared. That's possible. And then I could also do like 25 plus 2 squared. Really, you could go as crazy with this as you want. But here's where the kicker is. You have to kind of plug it into this, and judging on how you can do math in your head, which is kind of the point of them doing this, is, okay, so let's plug it in. So let me do the blue one. Let's do this one. Since it's subtraction, it's going to be like this: a squared minus 2ab plus b squared. So we get 30 squared minus 2 times 30 times 3 plus 3 squared. So this is 900. And this right here is the point of doing this way, because we can much more quickly get some of these numerical facts as opposed to just going, okay, let's do 27 times 27. And I even said in class, I'm like, listen, if you forget how to do this, and you can always do this, then you will be fine. But they really are trying to challenge your thinking to do this. Okay, so let's keep going. 2 times 30 is 60. 60 times 3 is 180, and then plus 9. So 90 minus 180 is 720 plus 9. So it's 729. So in theory, we were able to do 27 squared, potentially faster, potentially with less hassle. Depends, on how you look at it. Now let me do the red one just so we can compare, the two different ones. So this is going to be a squared plus 2ab plus b squared. Why is it plus? Why am I making that emphasis? Because this one is minus, so that's a minus. This is addition, so that's addition. 20 squared plus 2 times 20 times 7 plus 7 squared. This is 400. 2 times 20 is 40. 40 times 7 is 280 plus 49. So this is 680 plus 49, 729. And in my opinion, I think the better choice is going to be this one, because I'm faster at addition in my head than I am at subtraction in my head. If you are equally powered, cool, then do what you will. All right. So there was just 2 examples. You don't have to do it 2 different ways. There was just 2 examples. If you'd like to see the green one, why not? Let's just do the green one for everybody. 25 squared plus 2 times 25 times 2. And if you're like, why is that 2? That was part of the 2ab. But what about that 2? That's this 2 right here, okay? And then there's going to be plus 2 squared again because of that 2. 25 times 25, well, you know what? I don't know if I have that in my head. And so now we've kind of given a good example of like why maybe you don't want to do all of them this way. In fact, I'm literally going to grab a calculator so I can do it fast. It's 625. Maybe that's a fact you knew, and in which case, cool, good for you. Now, 2 times 25 is 50, times another 2 is 100, plus 4, because 2 squared is 4. 725 plus 4 is 729. So if you are a gifted 25 multiplier, then cool. I was obviously not as gifted a 25 multiplier as maybe you are. 40.5 squared. Okay, we could do 40 plus 1/2 squared. I like that one. I sitting here thinking through it, I really don't want to do one with subtraction, because what am I going to do? 41 minus 1/2? So pretty much, let's just go. Let's do 40 squared plus 2 times 40 times 1/2 plus 1/2 squared. So 40 times 40 is 1600. 2 times 40, well, here, you know what? 2 times 1/2 is 1. So 40 plus 1/4. This is 1640 plus 1/4. This is 1640.25. And you know what? I mentioned I had the calculator with me. 40.5 squared is 1640.25. If you want to leave it as 1/4, you go ahead. But see how, like, oh dang, that was doable, right? As opposed to, all right, I'm going to write, okay, as opposed to writing 40.5 times 40.5. I don't want to do that. But I get it. I am more prone to doing that. Here we go. This one breaks the mold of these two. So if you got to 12 and you're a little confused, 12 is going to look, it just looks different, okay? So what we're going to do is we're going to find the middle of these two numbers. So how am I going to do that? Is I'm going to add 5 1/4 and 4 3/4. I'm going to divide it by 2. So that is 10 over 2. So 5 is in between those two. And if you were like, yeah, I knew that already. Cool. Again, you super smart, me not so much. So the concept here is that, hey, 4 3/4 is here, 5 1/4 is here, 5's in the middle, and the distance is 1/4 between them, right? So what I'm going to do is I'm going to say 5 plus 1/4 times 5 minus 1/4. And if you're like, well, why would you do that? Because this gives me 5 1/4. This gives me 4 3/4. And now I can just multiply. This fits the mold or the pattern of a squared minus b squared. So what's my a? My a is 5. My b is 1/4. So I get 25 minus 1/16. Okay, so 25, because that's 5 squared, minus 1/16. That's 24 15/16. Not too terrible. And if you're like, but you know what, I could have done this otherwise. We could have 5 1/4 is really 21/4, and 4 3/4 is, let's see, 16, 19/4, and you multiply straight across. So I'd get 21 times 19, that's 9, that's 18, 0, 21, 9, 9, that's 399 over 16. Cool. 399, 16. Let's see, that goes in twice because that's 32, right? And that would be 79. And so since I already kind of know the answer is 24 something, I'm just going to write 4. 4 times 16, well, I got to do that math. 4 times 6 is 24. That is 64, and I'm going to get 15. Cool. 24 and 15/16. Which one was better? I don't know. But I guarantee you have not done this previously. You know what I mean? So there is 7-3. Let me know what questions you got.